Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the inductive AC values from the Chapter 16 math handout problem number 9. Alright, so we see here now that we are dealing with a parallel inductive circuit. I am going to get my known values that you see that I have here. I'm going to get those from my Chapter 16 math handout. Here is my total voltage, here's my frequency, and here is the value of my 3 inductive reactance values. Alright, so we see that we have the reciprocal formula to find total inductive reactance in a parallel circuit. So we're going to enter in our numbers to find XLT. So it's 1 over under 1 over under 200. Scroll over plus 1 over under 600. Scroll over plus 1 over under 150. It equals our total inductive reactance in this circuit is 75 ohms. I can use Ohm's law to find my total current. ILT is equal to VLT over XLT. So I have 120 volts over 75 ohms, giving me a total current of 1.6 amps. We see on our formula sheet here that current adds up in a parallel circuit. So we actually can go ahead and fill in all of our voltage values because voltage stays the same in a parallel circuit, parallel inductive circuit, just like it did in a parallel resistive circuit. Now that I've filled in all of my voltage values, I can find all of my individual current values using Ohm's law. So we did ILT already. Let's do IL1, 120 volts. Over 200 ohms gives me 600 amps. Next, I'm going to do 120 volts over 600 ohms, so I'll just change my bottom number to 600, giving me 200 milliamps. Next, I'll just change my bottom number from 600 to 150. Giving me 800 milliamps. 600 milliamps, 200 milliamps, and 800 milliamps should add up to 1.6 amps. It would not add up to 1600 milliamps. It would not be 1600 milliamps because 1600 would be greater than 1000. So you have to convert that to 1.6 amps. All right, inside of this parentheses here, we can use Ohm's law. In order to find L, what we cannot do is try to use the power formula by saying ILT times VLT would give you L. That will not work. You cannot use the power formula like that. That doesn't apply. The way that we find LT is by using formula number 15. So in this problem here, in this circuit here, you'll see that we're given our XL values. When we're given our XL values, we have to find our L values. In the next problem, problem number 13, you see that we are given our L values. So when we're given the L values, we're going to use formula 14 to find the X values. When we're given the X values, like we are on this problem, we'll use formula 15 to find the L values. values. All right, so L is equal to XL over 2 pi F. So I'm going to take my XL value of 75 ohms over 2, hit shift, hit the exponent button for pi, 2 pi times the frequency, 6.366 kilohertz. Make sure you do kilo. And it's 1.88 millihenries. All right, to find L1, it'll be XL over 2 pi F. It'll be XL1 over 2 pi F. XL1 200 ohms, so I changed the 75 to a 200. And that gives me 5 millihenries. For L2, it will equal XL2 over 2 pi F. So I'm going to change the 200 to a 600. Hit engineering, 15 millihenries. For L3, I'm going to use XL3, so I'm going to change the 600 to a 150. And that gives me 3.75 millihenries. If I want to check my work here, I can see with my formula sheet, formula number 8, that I would have to reciprocate these three values to check against my total value that I calculated using the reciprocal formula. Now that I've done all my calculations, I see the values that I will be asked for on the Chapter 16 Math Handout Canvas Answer Sheet assignment. So once I've completed all of these calculations on paper for the whole Chapter 16 Math Handout, then I will open the assignment and enter in all of the values asked for. Thank you.